Hi everyone, and welcome back to another one of our instructional videos. On today's video we're going to be showing you how to wire up your WorkBee 1010. In this video we're going to teach you how to wire up your LED light ring, your micro limit switches for a homing cycle. We're also going to show you the assembly process for each one of our drag chains, so that includes our X-axis and our Y-axis. We're also going to be showing you how to assemble your open case for your controller board, as well as many tips along the way. So let's go ahead and show you these highlight points now. So one really nice addition to this wiring system is our LED light ring. This is going to illuminate your whole workspace, guys, so any time of the day you're still going to be able to work on your awesome projects. Alright, so two more awesome additions to this kit, guys. We have our drag chain, which is also assembled with our OpenBuilds modular system using our single L brackets to mount this low profile look. Check it out, that is sleek, guys. We're also adding in our micro limit switches, so these are going to be configured into a homing cycle. This stuff is awesome, guys. And last but certainly not least, we have the OpenBuilds open case, which conveniences the builder to mount your controller to the back of your machine, which is awesome, guys. Super convenient. All your wires are coming to one unit, and as you can see, our fan's running currently, keeping our controller completely cool. Alright, so now that our highlights are pointed out and everything's going to be included in your kit, we're also going to be describing the settings as well as the values that you're going to input into your software. We're going to go through the process of downloading your OpenBuilds machine driver, as well as going through CAM applications to get your machine up and running. So without further ado, guys, let's go ahead and get started. Alright guys, so on this first step we're going to be assembling our female connectors to our 4-conductor wire for our motors. So in this step we're going to require a 12-foot cable of our 4-conductor wire, along with a 7-foot cable and 2 of our 2.5-foot cables. In addition to that, we're just going to need 4 of our female connectors. And also included in the kit, you're going to see male connectors, and that's for the purpose of attaching to your motors. So as you can see, I have all of my male connectors connected to every single one of my motors. So this is necessary, that way we can get a true connection with our female connector. As you can see, these adapt just like so. So basically what you're going to do is put your wires in this order. You're going to have red, green, blue, and yellow inserted into the pins, and we're going to match that with our female connectors. So if you haven't done so, go ahead and get that done first, and let's go ahead and get started. So with our female connectors, we need to make sure that our wires do correspond to each other. So just taking a look here at the connection, you'll see that red here is on the left side of the male pin. So here on the female, it's going to be the opposite, it's going to be on the right side. So we're going to work our way from right to left. So it'll be red, green, blue, and yellow. So if you have the new style of motors, which comes with the male connector already assembled onto the motor, your coil pairs are going to differ. So you're going to have red, blue, green, and yellow as your coil pairs. And as you can see how these are different, the motors with the leads, which we'll be doing in this video, those coil pairs are red, green, blue, and yellow. So for the new style of motors, we have red, blue, green, and yellow. So that's the difference. If you need to pause the video, go ahead and do so, that way you can see the difference in colors. But basically all you have to do, since these coils are already paired off for your convenience, you take your female connector and you're going to correspond your 4-conductor wire to each one of these colors on your motor. So you're going to have red, blue, green, and yellow. So you're going to be working right to left. Just make sure that you line up all of the colors. They need to correspond to your 4-conductor wire that's going to be attached to your female connector. And then this will relay to our controller. And from there I'll show you another set of wires attached to the controller, that way there's no confusion. Alright, so let's go ahead and continue. So basically with the lead extensions, we're going to be wiring these in particular throughout this video. So if you do have these motors, just follow along. If you have the new style motors, please pay attention to the colored wires and make sure that you wire it corresponding to your motor. Alright, so let's go ahead and continue. Also with these female connectors, you need to make sure to release the metal pins here. Go ahead and give you an example. As I loosen one of the pins, you'll see that the slot moves down to fully accept the wire. So make sure you loosen every single one of these pins, guys. Alright, once you have that done, we're just going to start here with one of the 2.5-foot cables. As you can see, all of these are pre-stripped as well. Basically what I like to do is leave about 5 millimeters here to insert into the female connector as well as the Xpro on the opposite end. Let's just go ahead and strip those down if you haven't done so. Alright, so we're going to start off by inserting red, green, blue, and yellow. So we're going to insert red and green first. And I like to fully insert the insulation into the connector. That way we don't have to worry about any type of cross connection between the two wires. Alright, and then next is going to be blue and then yellow. Alright, perfect. So just give those a tug, make sure that they're inserted and not coming loose. That looks good. Alright, so one of these 2.5 foot wires is going to go to our Y-axis. Let's just go ahead and connect that. As you can see, all of our wires to correspond. Perfect. Alright, so moving forward, we're going to do the same thing for all of these wires, guys. So let's go ahead and get that done. Alright, and this is going to go to our slave axis, which is our A-axis motor here on the right side, facing the back of the machine. Just go ahead and connect that. Alright, and this is our 7-foot cable here, and that's going to connect here to our X-axis. And for our last cable here, which is our 12-foot cable, we're going to go ahead and finish that one up, guys. Alright, perfect. So this one's going to attach to our Z-axis. Alright, perfect. Alright, now we have all of our wires connected. So let's go ahead and move on to the next step, guys. Alright, moving on to the next step here, guys. We're going to be assembling our micro limit switch kits. And we're also going to be adding our additional 2 conductor wire with our spade connectors. And we're going to configure this to our machine for a homing cycle. So as you can see, I have 2 of these assembled already in a horizontal configuration, guys. So this is just an example of how these mount to the plate, and also our 8mm screw along with our slot washer and drop-in T-nut, and this is how it will mount to the rail. So I have 2 of those completed. I've left this one that's broken out here so we can see all the parts that are included in the kit. We have a micro limit switch plate, micro limit switch, 2 of our M3 self-tappers, 1 of our M5 8mm screws, 1 of our slot washers, drop-in T-nuts, and 2 of our spade connectors. In addition to that, we're going to have a 7-foot wire here for our micro limit switch and 2 12-foot wires. So gather all those parts together, guys, and let's go ahead and get started here. Alright, so what we're going to do for this micro limit switch in particular, it's going to vary. So there are different configurations that you can set up for these micro limit switches. This one in particular, I want to set up in a vertical configuration, so it's going to run straight up and down on the plate. That way, for our Z-axis, we're going to mount it on the side of the C-beam. It's going to activate the pen with the wheels, and we'll get to that once we move on to the mounting process for these micro limit switches. But let's go ahead and mount this one here. As you can see on the back end of the plate, the holes are going to align with these 2 holes. So we're going to mount that with our self-tappers. Alright, perfect. From there, I'm just going to run my 8mm screw through the slotted hole here on the bottom, adding our slot washer. Make sure that your flat side is facing away from the plate, and this is for a secure mount to the rail. Alright, after that, you're just going to thread on your drop-in T-nut. Alright, and that's what the assembly should look like. Just going to set that to the side. Alright, from here we're going to go ahead and connect our spade connectors to our wire. And these are essentially going to attach to our micro limit switches. So I'm going to start here with my 7-foot wire. Just going to twist the ends here and make sure I get a secure lock. You're basically going to slide on your spade connector, and you'll see your wire here protruding through. So what we're going to do is use our wire strippers here on the clamping end, and we're going to clamp from the top just like so. Give that a tug, make sure that that's secure. That looks great. And we're going to do the same thing for our black wire here. Alright, perfect. That's one configured. So for this 7-foot wire, this is going to be for our y-axis. So we're going to use one of our horizontal configurations, since this is going to be set on the side of the C-beam and the plate's going to interact with the pin. So another thing that we're going to have to pay attention to is the order that we hook these up. On the micro limit switch, you're going to see indications here. We have C for common, and O for normally open, and C for normally closed. Now these configurations are based on signals sent from our controller board. So we're going to use a homing cycle. We're going to use our common and normally open configuration here. So common is going to be for our common ground. So that's going to be our black wire here. Alright, and the red wire is going to go to our normally open position here. Alright, perfect. So we're going to set this one to the side. Alright, and let's move forward here to the 12-foot wire. Same thing, guys. These are both 12-foot wires, so we're just going to connect them to both of these micro limit switches. Alright, perfect. So let's go ahead and hook this one up to our vertically configured micro limit switch. So same thing, guys, common ground and normally open. So red to the normally open and black to the common ground. Alright, perfect. So we'll put this one to the side as well. And let's move on to our last 12-foot cable here. Alright, perfect. So let's go ahead and connect that one. Same thing, guys. Black to common, red to normally open. Alright, perfect. So now what we're going to do, guys, is we're going to go ahead and rotate our machine. So we want to go ahead and rotate 180 degrees so we can see the front of the machine, and we're going to go ahead and assemble our mounting positions for our micro limit switches. So let's go ahead and get that done. Alright, now that we have the machine spun 180 degrees, we are now facing the front. Alright, so we're going to grab our first 12-foot cable here with our vertically configured micro limit switch, and we're going to run this right here in our front channel of the C-beam. And what I've done is I've brought this actuator all the way to the top position, so the wheel is bottomed out here on our C-beam end mount. And the reason for doing that is I'm going to find my placement here on the micro limit switch by activating it while I mount it. So right here in the channel, I'm going to find a position where it activates. As you can see, my pin is activated by the screw here, and then I'm just going to tighten that down, guys, just like so. And to test this, I'm going to bring my actuator down, then I'm going to bring it back up. As you can hear, the pin activates. That's exactly what we want, guys. Perfect. Alright, so I'm just going to take this wire and throw it over my x-axis. I know it's a bit of a mess right now, guys, but we're going to definitely make sure that everything's organized and labeled, so don't concern yourself with the mess. Alright, so our z-axis is configured. Alright, so for our x-axis, we're going to grab our additional 12-foot wire here. So right here in the back channel of our C-beam is where we're going to mount our micro limit switch. So the way I'm going to configure this is based on my y-axis here. I know that my workable material area is going to be to the right, so where my MDF starts is where I'm going to try to align my micro limit switch. So bringing it here to that channel, I'm going to go ahead and lock that into place, just like so. And if I were to move my gantry, that's going to be my homing position. That's perfect, because my router is going to be here, and that's all the room that I need. So if you guys want to move that over, it's completely up to you. If you want to configure it differently, that's also up to you. This is a modular system. We're just giving you guys a good example of how to set this up. Alright, perfect. So now our x-axis is configured. So I'm just going to put the wire with the rest here. And let's go ahead and move on to our y-axis, which is going to be our 7-foot cable. So coming here to the right side of the machine, where our motor is located, we're going to go ahead and align our Y micro limit switch right here in our C-beam channel. And once again, the plate is going to activate our micro limit switch pin. Let's go ahead and tighten that down. Alright, perfect. So now if we were to move our gantry forward, you'll see that it activates the pin. And that's perfect, guys. So we're also going to put this wire back with the rest. Alright guys, so let's go ahead and move on to the next step. Alright guys, so on this next step we're going to be assembling our LED light ring to our router spindle mount. So in this step we're going to require a 12-foot 2-conductor wire, our LED light ring, and our router spindle I just took off of our Z-axis. And you can see here I have marked points here to reference back to where I mounted it. So that's about 2 inches from our C-beam end mount at the bottom. In addition to that, our tooling, of course, our M5 ball driver and a flathead screwdriver. Alright, so starting off, we're just going to flip this router spindle over and we're going to take off both of our black angle corner connectors. And from there, we're going to mount our LED light ring. So as you can see, we have 4 holes in total here on our LED light ring, so you have mounting options. Since we're using black angle corner connectors on both sides of the router spindle, we're actually going to use those to set on top of the LED light ring. So these 2 holes here on the outer ends are what we're going to use to mount this. So let's go ahead and assemble our black angle corner connectors back to our router spindle. And make sure you keep the LED light ring straight and tighten that screw down. Alright, excellent. That looks really good. Alright, so what we're going to do now is just flip it back over. And let's go ahead and mount this back to our Z-axis. Like I said, I'm using my points of reference here on each side so I can align this. So now we have our router spindle assembled to our Z-axis. So now we're going to go ahead and take our 2-conductor wire here at 12 feet and we're going to attach it to our LED light ring. So right here we're going to have a positive and a negative indicator on the bottom of the LED light ring, so you can always reference to that. What I'm going to show you here, the right side here is positive, the left side is negative. So we're just going to loosen these pins first. And let's go ahead and insert the wire. Alright, give those a tug, make sure that they're fully inserted. That looks great. So now we're going to take our additional length of wire and toss it over with the others. Alright, and that's our LED light ring assembly. Alright, so let's go ahead and move on to the next step, guys. Alright guys, so moving on to the next step here, we are going to be labeling all of our wires and organizing everything for our drag chain assembly. So let's go ahead and get started here. I have painter's tape and a permanent marker. And I'm going to go ahead and identify each wire from the point of origin, and I'm going to label it accordingly. So here I have my X motor wire. You can also identify it by the conductor wire. Motors are going to be 4-conductor. Micro limit switches in our LED light ring is going to be 2-conductor. So this is our X motor. So I'm going to identify it as X. So I'm just going to pull off some painter's tape here. And what I like to do, instead of creating a flag, it is easier to write on, but it'll tear once you run it through your drag chain. I roll this all the way around the wire. So just like so. And from there, I'm just going to identify it as X. Just like that. Perfect. That's one down. So moving on, I am going to identify this as our Y micro limit switch. So I'm going to identify this as YM for Y micro limit. Just like so. Moving on to my Y motor here, we're just going to label this one Y. Alright, moving forward. Next I'm going to do my A-axis motor, which is on the opposite side of the machine. So this will be our slave axis. So So we're just going to label that one A. Next, I'm going to go ahead and grab my LED light ring, and we're just going to label that one LED. Next, we're going to move on to our Z-axis micro limit switch. And if you guys have any trouble identifying which axis is which, you can always refer back to the forum, and there's great descriptions and product visuals that can help you identify this axis. It's pretty basic. I'm pretty sure you guys won't have any trouble, but if you do, there's always resources out there. Alright, so this is the Z micro, so I'm going to label it ZM. So next we're going to move on to our Z motor, which is right up top here. Just make sure that you guys have these correct, because it is very important when we get to the Xpro and wiring. You need to make sure that all your axes are corresponding to the correct ports. So make sure that you do trace these back to the point of origin, guys. Next we're going to go to our X-axis micro limit switch, which is located here. And we're going to label this one XM. Alright, perfect. That's all of our wires labeled, so we're ready to go ahead and move on to the next step, guys. Alright guys, so on this next step we're going to be assembling our X-axis drag chain to our X-axis. So go ahead and gather these parts. We're going to need our slot cover, which I've cut down to 950 millimeters, so it can fit here in our cable tray. So that's a good place to start, guys. Go ahead and cut that down to 950 millimeters. In addition to that, we're going to have our X-axis drag chain at 1000 millimeters, a single L bracket, one of our M5 25 millimeter screws, two of our M3 8 millimeter screws, two of our M3 T-nuts, one of our M5 T-nuts, one of our 9 millimeter aluminum spacers, and our tooling we're going to use is M5 and M3 ball driver. Alright, so let's go ahead and get started here, guys. First off, by loosening the screws here on one of our Y-axis plates. These two screws we're just going to go ahead and take out. Alright, and the reason for taking those screws out is we're going to slide this 20x40 rail out of the plate. Just like so. If you need to lubricate the plate, I suggest using maybe like some silicone. So what we're going to do now is take one of our M3 T-nuts and slide it into the track. Make sure that your T-nut has the flange side facing down, and let's go ahead and slide that into place. From there we're just going to put our 20x40 back inside and fasten it back down. So let's go ahead and get that done, guys. Okay, so another suggestion here, if you have any trouble getting your 20x40 out or back in, all you have to do is loosen the other side as well. I'm simply just loosening these screws, that way I have some mobility here. Alright, so once you have the 20x40 in place, I'm just going to go ahead and fasten those screws back in. Alright, and if you did loosen the screws on the other side, let's go ahead and tighten those. Alright, so now that we have our M3 T-nut in place, we're going to go ahead and attach our single L bracket to our X carriage assembly. So let's go ahead and take our 25mm screw, running it through the shortest spacing here of the two. So as you can see here in the corner, we have a hole here that's closer to that edge. So we're going to use that to mount to our X carriage. So run your screw through there, add your 9mm aluminum spacer, and grab your M5 T-nut, and we're going to run it through this hole here in between our two screws here for our wheels. And then we're going to go ahead and attach that T-nut, and let's go ahead and fasten that into place. Alright, you just want to make sure to keep it as straight as possible so you can always even it out with your ball driver. Alright, perfect. So now what we're going to do is go ahead and take a look at our drag chain here. So one thing I will point out is this drag chain is modular, so you can disassemble these links and grow it or shorten it to any length that you desire. These end caps as well have to be configured properly to mount the way that we're setting this machine up. So both of these caps should look identical to what I have here. So it's a mirror image. This is exactly what you guys want. Alright, so now we're going to go ahead and take all of our wires from this side of the machine besides our X-axis micro limit switch. That's going to run through our cable tray with the slot cover. So we're going to go ahead and take our Z micro limit switch LED light ring wire, also our Z-axis motor, and we're going to run it through our cable chain. So what you can do to simplify this process, guys, is simply tape all the ends here. See how we have all these wires pre-stripped? So we're just going to go ahead and tape that with some of our painter's tape, just so we can keep this as one unit. We don't have to worry about these wires catching on the ends of the drag chain. So what I'm doing now is I'm just going to go ahead and pull the slack from the bottom end to our desired length. So as you can see here, I want to leave a little slack because we're going to bundle these wires together and hang them over our X carriage. So a bottom end of the drag chain is going to attach to this M3 T-nut that we inserted. All the additional length of wire is going to run through this square hole here, and eventually it'll go into our Y-axis drag chain. So first, what we want to do before we mount our drag chain is let's go ahead and take our X micro limit switch, and we're going to run that through the cable tray here. And what I like to do is start with the end point here, and I'm going to go ahead and run it underneath the drag chain with the rest of our wires. So let's go ahead and run these wires through the square hole here. Alright, and make sure you be careful of the edges of the square hole because they are sharp and they will strip your wire. Alright, so once we run all of our wires through our X micro limit switch wire, we're going to pull the slack out and lay it underneath our cable chain. So it's actually going to fit in the slot of the 20x40 here. From there, we're going to go ahead and take our pre-cut slot cover at 950 millimeters, and we're going to go ahead and insert this into the track to cover our wire. Alright, once you have the slot cover inserted, go ahead and show you what it looks like. It looks nice and neat. We've got everything tucked in. Our micro limit switch here is looking sharp. Alright, that looks excellent, guys. Alright, so now let's go ahead and move on to the mounting of our drag chain. So we're going to lay it on our cable tray here. And what we're going to do with this end cap is we're going to mount it from underneath our single L bracket. So we're going to find the center hole here, run one of our 8mm screws through. Run it through the single L bracket, grabbing one of our M3 T-nuts. We're going to go ahead and thread that on top of the screw. Just like so. Then grab your M3 ball driver, and we're just going to tighten that down. Alright, once we have that nice and tight, we're going to go ahead and take our additional M3 8mm screw, and with the center hole, we're going to mount into our M3 T-nut. Alright, perfect. Now we do have excess here that is hanging from the top, but like I said before, we want some slack here, guys, because we're going to run this over top of our X carriage. So let's go ahead and prepare our wires for that in particular. Just going to set them right over top of the X carriage plate, just like so, and we'll get to that later, guys. So now our X-axis drag chain is assembled. That's looking really sharp, guys. Alright, let's go ahead and move on to the next step. Alright guys, moving on to the next step here. On this step we're going to be assembling our Y-axis drag chain to our Y-axis here. So as you can see, I've already rotated my machine 90 degrees. And what we're going to do now is gather our parts. We're going to need our 1000mm Y-axis drag chain, 1000mm black slot cover, which I've already cut down to 950 millimeters. We're also going to need an end cap, 15mm screw, two of our M3 8mm screws, a single L bracket, two M3 T-nuts, and one M5 T-nut. Our tooling for this step is going to include our M5 ball driver, M3 ball driver, and a power drill. So let's go ahead and start this off, guys, by first taking off our double end cap here on the back end of the machine where our motors are placed. And we're going to end up using these two self-tappers so just go ahead and leave those out. So what we're going to do now is go ahead and grab our single L bracket and our end cap. And first we're going to go ahead and assemble our single L bracket to the bottom hole here on a 20x40. So taking the spacing that's closest to the corner here, we're going to go ahead and attach that to that bottom hole. Let's go ahead and grab a self-tapper, and let's go ahead and place that, guys. And we're going to go ahead and place our end cap as well. Alright, so once that's in place, we're going to go ahead and configure our drag chain. Once again, we're going to make sure that everything matches so we can assemble this properly. So we have both of our end caps in this direction, so they should be mirroring each other. Alright, so let's go ahead and grab our 15mm screw, our M5 T-nut, and our single L bracket here. So what we're going to do is find our hole spacing that we're going to use for our mounting of the single L bracket. So this hole here is where we're going to stick our 15mm screw. So let's go ahead and place that. And let's lock that into place with our M5 T-nut on the back end. And just straighten that single L bracket and then tighten it into place. Alright, now we're going to go ahead and take our drag chain. I'm going to go ahead and show you how we're going to be mounting this, guys. One of our drag chain ends is going to be attaching to our single L bracket on top using our left hole. And then our other end is going to mount from underneath the single L bracket, similar to our X-axis. And that's also going to be using the left hole. Alright, so first, before we mount our drag chain, let's go ahead and run all of our wires through the drag chain. Now everything's going to be included except for our Y-axis micro limit switch. That's going to run through our channel with a slot cover. Alright, so let's go ahead and run all these wires through. And like we did with the X-axis, I've bundled all these wires together with masking tape or painter's tape. That way they all stay together as I'm feeding this through. Alright, so now that you see your wires coming through, we're just going to pull that additional slack through our drag chain from that bottom end. Alright, perfect. So once again, we want to leave a little slack here. That way we can mount our drag chain. So what we're going to go ahead and do now is grab one of our M3 8mm screws, one of our M3 T-nuts. We're going to run it through that left hole on our drag chain. And let's go ahead and mount that to our single L bracket. Alright, now I'm going to grab my M3 ball driver and just finish tightening that. Alright, so now let's go to the opposite end of the drag chain, and once again we're going to grab our M3 8mm screw and our M3 T-nut, and let's go ahead and run that screw through the top of our drag chain. What I'm going to do is pull my machine back slightly, that way I can tighten this from the bottom. Alright, and grab your M3 ball driver and let's tighten that down. Alright, excellent. So I'm going to push my machine back. Alright. So now our Y-axis drag chain is assembled. So we're just going to take all of our wires and throw them towards the back of the machine here with our additional Y and A-axis motors. And let's go ahead and configure our Y-axis micro limit switch. So what I'm going to do is go ahead and run this through the track of the C-beam here behind our Y-axis plate. And from there I'm going to take my slot cover, and we're going to go ahead and insert that into the slot. Alright, perfect. And what I like to do is run this micro limit switch wire behind the plate here, so there's no interference when the plate interacts with the switch. Perfect, man, this is looking slick. This is really nice, guys. So we're just going to take that Y-axis micro limit switch wire, and we're going to throw it back with the rest. Alright, now let's go ahead and move on to the next step. Alright guys, moving right along here. On this step we are going to be wiring up our Xpro controller. So in this step we're just going to need our Xpro controller and a flathead screwdriver. And what I've done here is I've simply taken the plastic sheet here of the diagram of the Xpro, and I'm using that as a nice clean plate to set this Xpro on. So let's just go ahead and grab one of our wires here. So all of our wires have been configured to the back of the machine. So we're going to locate one of our wires, and checking the label here, this is our X micro limit switch. We're going to go ahead and locate that position on our Xpro controller. So just to give you a brief overview of our Xpro controller here, each axis is labeled. So our A axis, which is our slave, will be our fourth axis. We're just going to run in unison with our Y. We've also got our Z axis and then our micro limit switch, and then here on the other side we have our Y motor and our Y limit switch, X motor, X limit switch. So what I like to do is configure the Xpro in this direction, so my power cable will attach here from the right side. Now you can configure this any way that you want. This is just the way that I'm going to show you how to do it. It works best for us. So to start off, guys, we're going to go ahead and locate our X micro limit switch. So it's going to be here on this end. And what I'm going to do is go ahead and loosen these pins. Alright, from there I'm just going to twist these wires, making sure that they're nice and uniform. Alright, so we're going to have our positive on the left side here. And this symbol here stands for our ground, so that'll be our black wire. So we're just going to insert both of these at the same time. And then tighten it down. Alright, give those a nice tug and make sure that your insulation is fully inserted into your connector here. We don't want any cross connection here, guys. So that's perfect. Alright, so now I'm just going to go ahead and locate my X motor so we can finish off this location here. Alright, and here's the X motor, and you can also tell because we're using 4 conductor wire for the motors. Alright, so let's go ahead and prep these wires and loosen these pins. Alright, so from left to right, we're going to work our coil pairs, which is going to be our red, green, blue, and yellow. So first I'm going to start with my red and green. Alright, so if you have the new style of motors with the male connectors attached to the motor, this is how you're going to wire up your controller. So this is all based on the coil pairs. So we have red, blue, green, and yellow. And that's going to follow on every single axis. So as you can see, there's no difference in the ordered pair on either one of my axes. Okay? So that's for a lead screw driven machine. Now with a belt drive that will differ, and throughout that video I do show you the same exact picture here of the controller setup. So if you do have the new style of motors, make sure that you follow this, pause the video if you need to, but these are the coil pairs and how they're going to align to your controller board. And you need to make sure that every single one corresponds. So if you were to look at the new style of motors, and if you were wiring your motor directly into your Xpro controller, you can see we have it aligned. So this is just based on the motor coil pairs aligning to your controller. The only thing that we're doing is we're adding that extension length, which is going to connect to our male connector here from the female. And all of those connections are going to relay to your controller, and it comes back to the simple concept of the motor coil pairs just aligning to the controller properly. That way when you configure this into the software, you have no problems. So just make sure you pay attention to this, and if you do have the lead extensions, which are what we hooked up to our motors here, those lead extensions coil pairs are going to be red, green, blue, and yellow, and those will be configured in this video. So I'll be showing you how to insert each wire into the pin and clamp it down. And the micro limit switches, of course, for this controller, this is all going to be the same. The only difference is the ordered pairs of your motor coils. So make sure that you pay attention to this, guys. I'll also add a link in the description for this diagram, both motor and controller. That way you guys do have a diagram that you can look at. But this is pretty simple, you just need to make sure to get it correct. Alright, so let's go ahead and continue. Make sure they're fully inserted, and let's go ahead and tighten that down. Alright, next is going to be blue and yellow. Alright, perfect. So that's one motor and micro limit switch down. So let's go ahead and move on to our Y axis. So here's our Y motor. So same thing, guys, we're going to do red, green, blue, and yellow, and then red and black for our micro limit switch. So let's go ahead and get that done. Alright, so let's go ahead and move on to the next axis. Just going to rotate our Xpro. Alright, now let's go ahead and locate our A-axis motor. And same thing, guys, since this is going to be a slave axis, we're going to invert it in our software. So we're going to align this the same way as we did the others. So red, green, blue, and yellow. Alright, give those a tug, make sure that they're inserted correctly, and that looks great. Alright, so we're going to go ahead and move on to our Z-axis. It's the same exact thing, guys. Red, green, blue, and yellow, and then red and black for our micro limit switch. Let's go ahead and loosen all these pins, and we'll go ahead and get those wires established. Alright, give this a tug, make sure that those wires are inserted properly, and that looks great, guys. So now we have our Xpro wired up, so let's go ahead and move on to the next step. Alright guys, so moving on to the next step here. On this step we're going to be assembling our open case to our Xpro controller. So go ahead and gather these parts here. We have two of our open case plates, our Xpro of course, two of our M5 15mm screws, two slot washers, two drop-in T-nuts, two M3 aluminum spacers, two 3mm aluminum spacers, 8 of our M3 T-nuts, 4 of our precision shims, 4 of our M3 hex standoffs, 12 of our M3 20mm screws, 4 of our M3 12mm screws, and our brushless fan. Our tooling, we're going to use our M5 ball driver and M3. So let's go ahead and get started here, guys. First, by assembling our Xpro to our open case, we're going to go ahead and place our Xpro on the open case. And as you can see, it's going to line up with 4 holes here. So we're going to run our 12mm screws through each one of these points. Alright, from the back, we're going to attach our M3 T-nuts to each one of these screws. So what I like to do is just thread them on top of the screw. And what I'm doing here is just self-tightening each one of these screws. Of course, you can use your ball driver here, but the reason I like doing these by hand is because I don't want to over-tighten this system. I want to make sure that there's no flex in my Xpro, and that looks really good. So it's on there, it's mounted securely. I really have no reason to tighten it more than that because I do not want to bend this board. Alright, that looks great, guys. So now we have our Xpro mounted. So what we're going to do now is go ahead and on each one of our corners, we're going to run our M3 20mm screws with our hex standoffs. So let's go ahead and grab those screws, just like so, and grab one of your hex standoffs. We're just going to thread that onto the screw. And this is in preparation for the top portion of the open case. Alright, so let's do that for our additional 3. Alright, perfect. So now that our hex standoffs are in place, what we're going to do now is utilize these two holes next to the bottom of our case for our M5 15mm screws. We're going to run each one of these through, and this is for our mounting process to our extrusion. So our 20x40 here, this plate's going to mount directly to that. So go ahead and run your screws through each one of these holes. And from the back, we're going to add our 3mm aluminum spacer, our slot washer. We're going to thread on our drop-in T-nut. And let's do the same thing for this side as well. So now we're going to go ahead and assemble our fan. So on our next piece of the open case, we're going to go ahead and run our fan with the sticker facing towards you, because this is where the airflow is going to come from. So once again, we're going to take notice to our hole spacing here. So you can see which ones line up with the fan. So they're the outer holes right here. Alright, now we're going to take our M3 20mm screws, and we're going to run them through each one of these holes, guys. Alright, we're going to place that flat on the case, and we're going to add our precision shims next for spacing. And let's go ahead and place our fan on top. From there, we're going to add our M3 T-nuts. And once again, I'm just going to hand tighten these. You don't want to over tighten it. Alright, perfect. So now we have all of our things configured here. We have our Xpro and our fan configured on each one of our plates. So these 4 additional M3 20mm screws, we're going to carry over into the next step. So I want to leave this case open so I can show you the assembly of our power wire. It's going to insert into this blue connector. And from there, we'll go ahead and move on to the next step, guys. Alright, so moving on to the next step here. We are going to be assembling our 24-volt power supply, encasing our Xpro, and in this step we're going to gather these parts, guys. So we have our open case, which we have already configured with our Xpro and our fan. We're going to need 15 zip ties, and these are our slot covers. So when we cut down our slot covers to 950mm, we were left with 2 pieces here. So we're going to be utilizing those on our organization for wire management. So go ahead and pull those out, as well as the zip ties. We're going to need our power wire for our power supply. We're also going to need our power wire to our Xpro. It should have 5 feet of cable. And our tooling for this, guys, is going to be our M5 ball driver, M3 ball driver, and our Phillips screwdriver. So let's go ahead and get started here first by pulling our 24-volt power supply. What we want to do is make this adjustment on this right side of the power supply. If you're in the States, you're going to want to engage the 115 volt. So let's go ahead and loosen our terminals here on our 24-volt power supply. Alright, so now that we have our power wire, we're going to go ahead and take notice to our 3 different colored wires. We have black for line, white for neutral, and green for ground. So here on the power supply, you're going to see your ground, which is going to be green, and for neutral, L for line. So in this order, guys. So by simply inserting all of these wires into the terminals, we're then going to tighten these down. Alright, give those a tug, make sure they're not coming loose. That looks great. Alright, so now we're going to go ahead and take our power wire that's going to provide power from our power supply to the Xpro, and we're going to mount that on the output section. So here you're going to see 3 and 3 terminals. So we have positive and negative. We're going to utilize these 2 terminals here. So obviously black is negative, red is positive. So let's go ahead and loosen these 2 terminals. Alright, once they're inserted, go ahead and clamp down. Alright, perfect. So now let's go ahead and move to the Xpro. So here on our connector, we're going to go ahead and loosen that. And here you have indications of our positive and negative, so just make sure you match those up. And make sure they're fully inserted and tightened down. Alright, perfect. So now that we have that assembled, we're going to go ahead and zip tie our power wire right here on our open case. So you see these 2 slotted holes here. We're going to go ahead and run a zip tie in there to make sure that there's no pulling force on this end. You do not want these cables to come loose, guys, because it will fry your board. So let's make sure we get a zip tie in there. Alright, perfect. So any type of pulling motion, the zip tie is going to absorb that force. So let's go ahead and snip the excess. These are just snips that I use. You can use scissors, anything to cut this, just to make it look nice and aesthetic. That looks great. Alright, from there, we're going to go ahead and connect our fan. So here you're going to have a connector that's attached to your fan. And on the Xpro, you're going to see this section here, and you're going to have a positive and a negative. Our red wire is going to go to our positive, and the black to the negative. Let's go ahead and plug that in, just like so. And then we're going to go ahead, and what I like to do is I like to keep these wires coming out in the same direction. So as you can see, all of our wires coming out to the left side here. And what we can do is go ahead and zip those into a bunch. So let's go ahead and zip tie all these wires together. So obviously what you can do is trim these if you want to make a shorter connection to your Xpro, depending on where you want to configure it on the back of the machine. For us, I like to keep the excess wire just in case I want to configure this differently, moving the Xpro down further or mounting it somewhere else. That way I always have that additional length just in case I want to use that mobility. So in this case, we're just going to go ahead and bundle these wires together. And while bundling these wires, make sure that you don't strap in your LED. Your LED light ring is going to attach to our power supply. So just leave that one out. Alright, so once these wires are bundled, go ahead and take a zip tie, and let's tighten this down. And from here, I like to align it to the bottom of the open case. That way we still have room for our fan to blow onto our Xpro. And from there, we're going to go ahead and encase it. So go ahead and take your M3 20mm screws, and let's tighten the system down. Alright, so once you have that tightened down, we have a nice unit here, which is really nice, guys. So what we're going to do now is go ahead and zip tie our additional length here coming out of our open case. That way we can keep everything nice and uniform here, guys. And you can always configure this differently. This is just a good example of how you can manage your wires, but this is completely up to you how you want to do it. Alright, and here on the connectors, I like to zip tie these in place so you don't have to worry about your connectors coming loose. So I simply go through the wires and then I tightly zip tie it. Alright, now for the LED light ring, we're going to go ahead and bring that over to our power supply. And the same that we did with the power wire for our Xpro, we're going to do for our LED light ring. So what I'm going to do is I'm going to run my positive to this terminal and the negative to this terminal. Let's go ahead and loosen those. Just like so, and tighten it down. Alright, perfect. That looks great. Alright, so now we're going to work our way around the machine and zip tie all these points to make sure everything is going to stay in place and we don't have any connections coming loose. So working our way over here to the left side, since we have most of these zip tied, I'm going to come underneath the motor here and zip tie the wires from the drag chain coming out. So right here at the end point, we're just going to zip tie all those wires together. Alright, so let's grab another one of our zip ties, and we're going to work our way over here to the left side of the machine. And these additional wires we're going to go ahead and zip tie together. What you can actually do is go around the spacer so it's securely attached to the motor. Just like so. Let's go ahead and cut off that excess. Alright, once again for this connector, we're going to zip tie that. Alright, it's really shaping up. So now let's go ahead and move to the Z-axis. And this is where our slot covers are going to come into play. On this front slot of the Z-axis, we're going to go ahead and place our slot cover to contain these wires. Alright, once you have the slot cover in place, we're going to go ahead and zip tie all of our wires together here on the X carriage. And one more zip tie here on our connector. And one more zip tie here on the A-axis. So now what I like to do is, since the A-axis is coming out on the right side of our open case, we can take our additional slot cover and attach it right here in the bottom track over 20 by 40, and that way it holds it into place. Alright, perfect. So now that we have all of our components configured here, we're going to go ahead and attach our open case to the 20 by 40 rail. So grabbing our ball driver, we're going to use this slot here to attach to the screw. From there we're going to slide our drop-in T-nut into the track, and we're going to go ahead and tighten that down. And same for the other side. Alright, perfect. So now that we have all of that configured, this is looking really sharp, guys. Alright, so let's go ahead and move on to the next step. So in this step, we're going to go ahead and plug in our USB cable to our Xpro controller. So here on the top portion, you'll see a serial port. We're going to go ahead and connect our USB, just like so. And from there, we're going to go ahead and connect our USB into our laptop. Alright, now let's go ahead and move on to the software portion. Alright, so on the software portion, we're going to go over our settings and where to download our machine control driver. So first we're going to open up our browser. And from there, we're going to go ahead and type in OpenBuilds. Now up top here, you're going to see our tabs. Here's going to be a selection for software, videos, and different applications that apply to multiple things that we use here on the OpenBuilds store. So go here to software, and here you're going to see options to download the Windows driver for the OpenBuilds control machine driver. So we're going to go ahead and download. We're using Windows, but you have other options for Mac and Linux. Let's go ahead and select the download, and you can see down here in the left corner it's downloading. So now we're going to go ahead and select it, and here you're going to have information that says Windows protected your PC. We're going to go into more info and run anyway and go through the prompts and install. Alright, we're going to finish, and then you're going to see that the driver has started. Alright, so now that we have our OpenBuilds machine driver opened, we're going to go here to the COM section, and we're going to select the COM that we're connected to, which is COM 11, and let's go ahead and connect. Alright, now we don't have power distributed to our controller yet. We do have 5 volts that's being provided by our computer, but we're not powering on our power supply yet. So make sure you guys don't turn that on yet. We're going to go ahead and adjust the settings here. So go ahead and select Gerbil settings, and here you're going to see options to populate Gerbil parameters from machine type defaults. You can customize values as needed below. So right now we have a couple options here. So we're going to go back to OpenBuilds, and we're going to locate the settings for our machine specifically. So going through the form here, we're going to select OpenBuilds machines, and we're going to locate the WorkBee 1010. It's right here. Once we select that, you're going to see detailed descriptions of our machine, the parameters, travel, a lot of different specs for the machine in particular. We're going to keep scrolling down until we see Gerbil settings. So right here, you're going to see WorkBee 1010 Gerbil settings. So we're going to go ahead and click to expand. And I'm going to minimize this screen here so I can copy these values right over into our machine driver. Alright, so starting with 0 here, you can see the value is 10. That's correct. And we're just going to go on down real quick, guys, and input all these settings. Alright, for 1 it's 255, that's correct. Step pulse invert is at 0, that's correct. So going on down, we have 3, which is set for 4, and that's our step direction invert. So in order for our machine to run in unison with our x-axis and y-axis, since it is a Cartesian style machine, we need to make sure that we invert the A, which is going to be our y-axis. So let's go on down to 4. That's set at 1, so that's enabled. 5 is disabled. 6 disabled. 10 is going to be set at 1. That is correct. So go to 11. That's going to be 0.020. That's correct. Going on down to 12. That's correct. 13 is also disabled. 20 disabled. 21 disabled. 22, we are going to be running a homing cycle, so we're going to enable that since we have our micro limit switches hooked up. Okay, so homing direction invert should be set at 0. It's going on down to 24. Alright, and this is going to be the locate feed rate. We have that set to 100, so we're going to go ahead and put in 100. Alright, 25 is going to be at 1000. 26 is at 250, that's correct. 27 is going to be at 3, so that's the pull-off distance for the homing cycle. Alright, 30 is at 1000. 31 is 0. 32 is disabled, that's our laser. 100, so this is going to be our values for steps per millimeter. Now with the lead screw driven machine, we found the most accurate steps per millimeter is 199.100. What's also cool about this software here is you have calculators, so you can calculate your values based on what type of components you're using for transmission. So we're using lead screw, so you would put in those values if you wanted to do it this way. We're showing you exactly what to put in, so all these values are calculated for your convenience. But this is a really cool option, awesome on the software side. Definitely a very convenient way to just calculate, what kind of configuration you're using. So since this is all lead screw driven, we're going to go ahead and put in this value, 199.100, on down to the z-axis. Alright, and here we have our maximum rate for all axes. So millimeters per minute, we have 2500 set for all 3. That looks good. For a lead screw, I really wouldn't go over this. That's a nice speed for a lead screw. You can actually go down if you want to decrease the speed for more accuracy, or depending on the material that you're cutting. So these values are good. Alright, so 120, we have 150, same for 121, and 122. Alright, and 130, these are going to be all of our maximum travels. So 824 for our x-axis, 780 for the y-axis, and 122 for the z-axis. Alright, now that we have all those values inputted, we're going to go up to the Save to Firmware tab. And we're just going to go ahead and select this, and it's going to save all of our parameters and values. Alright, so now everything is configured properly. So now we're going to go ahead and jog our machine around, guys. Alright, so after jogging the machine around, we're going to make one tweak to our settings. We're going to go down to our homing direction invert. So here at 23, we're going to go ahead and adjust that to our value of just 3. Now that's going to invert Z only, and this is going to give you a proper homing cycle. So make sure you change that setting, guys, and let's go to Save to Firmware, state yes, and it's going to update your firmware to your board. There you go. Alright, so let's go to Control, and what we're going to do now is go ahead and jog the machine around, get a feel for our increments, our speed, and which direction goes where. So I'm going to go ahead and put my settings to 1 millimeter movements. I'm going to go ahead and jog my Y first. Now, positive movement, the machine is going to move out into the field. So as you can see, once I make this movement, let's go ahead and bump that up to 10 millimeters. Man, this machine runs great. Look at that. That's awesome. So it's moving back into the field. So that's a positive movement. Now if I go to a negative movement, it's going to go back to our home position. Alright, now same for X. So if I hit a positive movement, it's going to move to the right, out into the field. Left, back to our homing position as a negative movement. Now I'm going to bump this down to 1 for our Z because we have less travel. Now a negative movement would be down into the material. So as you can see, it's moving down into the material. Positive movement is going to be up away from the material. Perfect. Everything looks great. So what I'm going to do now is go ahead and bump my increments back a little bit and move my Y and my X so you guys can see the proper homing cycle. Alright, so now up at this section where our tabs are, we're going to hit Home All. Now if you have any issues, make sure you just hit Stop Job. It's immediate. Your machine will stop. So let's go ahead and hit Home All. It's going to start with a Z, and it found the homing switch. And now Y and X. Perfect. That looks excellent. So our machine is all set up. We have our settings configured properly. So now I'm going to show you some more additions to our software, which is really cool. We have troubleshooting here. So you can actually press your micro limit switches, and each one is going to indicate if it is receiving a signal from your Xpro. So I'm going to hit Y. As you can see, it says on, off, and so on and so forth for X and Z. You even have a probing option here, which is really cool stuff here. Alright, so we're going to go back to Gerbil settings here. So this is new. We have select machine. As I was stating before, you're going to hit this and you're going to have options for your machine in particular. So we've got our OpenBuilds WorkBee 1510, OpenBuilds Sphinx 55. All these machines are going to be inputted in here, so it's going to simplify the process of entering in our values for our firmware. So the OpenBuilds WorkBee 1010 is going to be inputted here, so you guys are just going to click that, and all of your settings are going to be inputted correctly. So you don't have to concern yourself with going back and forth from the website. Even though it's not that much of an inconvenience, this is really cool. And it's also got options for limit switches installed. So once you select this, it's going to configure that into your firmware. Really cool stuff. So let's go back to control. So we also have a jog widget. So when you select this, you can scan it with your phone, and you can jog your machine with your phone. Super cool. All right. In addition to that, of course, you can open your G-code here. You've got tooling options, so you can actually run these off the output of your Xpro. Tooling options, coolant options. That is awesome. Love it. And we also have the 3D viewer, which is super cool, guys. You can actually watch your machine working live. And you can actually adjust this too. So you can scroll in, scroll out. You can change the orientation. I mean, this stuff is state-of-the-art. Awesome, powerful software. I love it. It's really cool. Alright, and you can also simulate this. You've got a reset view, simulate, so you can watch the machine where it's going to start, how it's going to cut out your design. You can speed up the simulation. Really cool. Alright, so what we're going to do now, guys, is we're going to go ahead and upload our Hello World to our machine driver. And that way we can watch our machine, do an air cut, and watch it work, and we're going to see our machine alive. So let's go ahead and go back to our browser, and we're going to go back into the OpenBuilds tab. And under software, here you're going to see OpenBuilds CAM G-code generator. So go ahead and browse to, and it's going to go ahead and open up your CAM G-code generator. If you've used this before, it's going to go ahead and show you an option for recover last used workspace, which is really cool. You can save this. The software is smart, so it's going to recover your last used workspace if you want it to. We're going to start with a new workspace. And now we're going to go into settings, and from here we're going to set up our parameters for our machine in particular. So go ahead and pull up the drop down menu and select OpenBuilds WorkBee 1010. And of course your controller is the Spark Concepts Xpro. And here for select your tool, we're going to go ahead and turn that off. We're not using a tool currently. This is going to be an air cut. And let's go ahead and save that. Alright, and from there we're going to go back to our workspace. And we're going to open up our Hello World example. Let's go ahead and select that. And from here, it's going to go ahead and calculate your toolpaths. Alright, now we're going to go ahead and select Generate G-code. And from there, it's going to show you all the toolpaths. Alright, perfect. So now from here, we're going to go ahead and transfer the G-code to our machine driver. Alright, and you can see on our 3D viewer, all the toolpaths are populated. Check that out. That's awesome, guys. All right, so now we're going to go ahead and run this job. So before we do that though, we want to go ahead and set our 0 point. So as you watch my machine, I've got this set to 1 millimeter increments. I'm going to go ahead and adjust my machine into a 0 point. So moving my X to the right, just to give myself some room, bringing my Z-axis down, and I'm also going to bring my Y-axis out into the field slightly. Basically what I use is my router mount for an example. So if you did have a router inside your router spindle mount, you would be able to locate the position by bit. So from here, I'm just kind of eyeballing the location, and then I'm going to go ahead and set my 0 point. All right, everything should zero out. That looks great. So let's go ahead and run this job. If you guys have any issues, make sure you hit stop job. It's immediate. But look at it go. So here I'm watching my 3D view. Check that out. This is really exciting, guys. Your machine's up and running. It's alive. So please tune in and subscribe to our channel. And make sure to keep up to date with all of our future builds coming out. And good luck with all your future builds.